I've made very good progress now in scraping in the top slide and the cross slide, and I've now reached the point where I think I'm happy enough and I can't really do much better. There's quite a bit of wear here where it's been chewed around over the years, and there's a little bit on this side, but the main problem was that this was very much worn in this point, so when you wound it to the far end here, it jammed up quite solid if there was any free movement. Now I've got it so that if I put it in the middle position here and tighten up the screws so that there's no movement in there, and then wind it back, it moves smoothly and without any effort from one end to the other. There's no movement or rock in this from one end, either at one end or at the other end, and that's nice and smooth. I used rod that I bought, which is trapezoidal in form, left hand thread, and I explained before how I took out the bronze nut, drilled it out, and made up an insert. I made up an insert to go in, and I did find it was just a little bit on the loose side, so in the end I decided that I'd split it, so I sawed down here, just nipped that up, so when I put it back into the hole that I machined, slid it in, tightened up the nut, the screw that holds that in, the previous one in place, it just kept that nice and tight. So I'm pleased with that. So the net result of that, I'm sure you should be able to hear it, there's no play in this direction, and in this direction just a fraction, which is probably coming from this end slightly, but I'm not going to mess with it anymore now. It's less than 0.1 of a millimetre movement, and this cross slide I'm really really happy with. I did this in the traditional way. I measured the dovetails. I measured the dovetails with dowel pins, and made up a little chart, and had, when I first started, that's my second attempt, I haven't got the other one here, but it was 0.18 at the widest, at the least worn section, and 0.1 at the point that was the most worn at the far end, and I've scraped out the dovetail on this side away from where the gib is, so that I've now got 0.12 right the way through from there to there, and it's just a little bit looser at this end, but it doesn't matter because there's a huge amount of movement, just a tiny bit there. But when am I ever going to be machining in this position? Never, I would think. And when the time you get it to that position, there's no movement really at all, and it's beautifully free, smooth as silk. So that I'm well pleased with, and it runs all the way through. As you can see, it's a massive long table on the cross side, right the way through. Difficult to believe it is quite so far. That's a really long thread on there. So it goes right up to that point there. So and it's rock solid, of course, at that point, rock solid all the way down to the centre, machining up into the centre of there. So yeah, that's very good. So no movement at all in the top section, and no movement at all until it just gets past the point where I'm ever going to be machining in this section. So really quite a successful effort so far. The dials here have a split in them so that you wedge a screwdriver in, and that allows you to remove them, and if you take that out again it nips it up again, which is all very well, but you can't freely turn them. So what I did was, on this one I've put a grub screw in here. There's a spring underneath it and a small pad of brass rod, so that this can move about and I can quite readily use it as an adjustable marker position, same as I've got on the Boxford, and it doesn't really detract from the originality. And this one, curiously enough, has this little funny handle in the end instead of the normal handle, and it didn't have a screw in the end of it either, which is a bit strange. I made a start on restoring this lathe, and I know a lot more about it than when I first got it. I've had a go at the top slide now, and that now moves nice and freely, having scraped it in from one end to the other. Unfortunately there are some marks at the end where somebody's been a bit careless, but they don't really affect it in its operation at all. I've mounted a separate tool post on the top, which I did on my rivet lathe. It's the most useful way of being able to use modern tooling, and it meant, unfortunately, drilling a hole into this block here. I first of all put this block into my mill and took 4mm off it, which was just enough to be able to give me the clearance I needed to be able to fit a tool holder. And I've of course scraped this after having fitted it so it's nice and flat. When I took the thread, feed screw out of the top slide here, I discovered it was a 2mm pitch thread, which was what I was expecting, but what I wasn't expecting was that it was a right hand thread, and if you look on this end, you can see there's a little arrow here which gives the movement in one direction, and the direction of the turn of the screw is shown there. So if you turn this to the left, it advances the carriage in that direction, and that's the opposite way round to all the other lathes I've got. Why on earth it's running backwards like that, I've no idea. It does of course have implications as to what I can do with the lead screw, and I'll come to that later, but it does mean I decided that I'm going to change the feed screw from right hand to left hand thread. It needed a new lead screw and nut anyway, and I bored this out. There was just enough room to be able to get that bored out and to be able to fit a new screw in, a new nut in, and that seemed to me the neatest and easiest way of doing. I was going to remake the whole thing first of all, but that this is a simple way of doing it. Some interesting threads on this lathe. It's difficult to really understand. I thought it'd be all metric. That's a 9 threads per inch, and difficult to know why they didn't use a metric thread, but it's 9 threads per inch. It's a metric dimension. That's 31 millimeters. It's slightly tapered, which makes it nice and tight to screw on. 31 millimeters, and as I say, 9 threads per inch. Why it would be an imperial size, I've no idea. This is the nut that feeds the cross slide, and I was able to fit in the same way. I bored that out, mounted this in the 4-jaw chuck, and simply bored it out. And this is just sitting in here loosely at the moment, held in with this pinch bolt. But I probably put Loctite as well as screwing this up as tight as I can. But that seemed like an easy way of renewing the nut, so that it's threaded the other way and a fresh thread. So that's that. One consequence which is a little bit annoying is the dials on the cross slide and the top slide are of course metric, so that says 12 on that line and 8 on that line, so it's 12, 11, 10, 9, 8 and so on round. That means that as this is advanced, it's running back to front, but that's a small thing to cope with. This had only divisions on for each 0.1, so that's 20 is 2 millimeters, so these are 0.1 millimeters, and the individuals are, I've put extra divisions in because it was quite handy if you're doing threading to be able to have smaller divisions than that. So that's the dial on the top slide. The dial on the top slide is, sorry, on the cross slide is slightly more delicate, and you can see that the thread on this is just a straightforward V thread. It's not an Acme or anything, or square, which is perhaps a bit surprising. But the nut had worn more than the thread. The threads are not too bad on here really, but never mind, I'm replacing them. A headstock, that came with one collet. I made up a centre just so that I can use it for laying this out and testing it. The spindle's not in too bad order. It did need a bit of polishing up. It's run in typical early fashion in glass hard seats, so the bearings here are very, very hard. They've been hardened, and they run in, I think, cast iron, but difficult to tell. It has been run without oil in for a while, and it's a bit scored in places, but I've polished them out as best I can. In the back of the spindle, up against inside here, there's a ball race that takes the load. I haven't cleaned this up yet, but there's a ball race in there which I took out. It's still in good order, so I'll just give that a clean and pop it back in again. I've made up a new back plate for an old chuck that I had resurrected. The lathe's quite big enough to take a 5-inch chuck. And this is a grip true one, so it'll be capable of adjustment. The cross slide is in reasonably good order. It just had very little bit of scraping at one end, but it's very long here, a long bearing surface, and that's probably what saved it. It's really not worn much at all. So I'm reasonably pleased so far. The one thing that is going to give me a lot of work though is the bed of the lathe. This, as it turns out, it is low in the middle, high at the end where it's underneath the headstock, and high at the tailstock end, and it's 0.09 of a millimetre of a dip in it, 0.09, and there's also a dip in the top of the V-way on this side. So I'm thinking what I shall do is, I've got an engineer's straight edge. I'll scrape this edge flat and level, and then I'll scrape this flat and level, and then after I've done that I'll scrape this edge using my straight edge across at an angle. I think that should work, and I can print off it. I can do this one with the straight edge because it's only a fairly narrow surface, and also that's not a terribly large surface, but angled over it's going to be a little bit awkward. So it's going to take an awful lot of work, but it'll be interesting to do, and we're still not out of lockdown yet.